Alright guys, let's go ahead and do number 1 together. It says a child rides a sled that descends at an angle of 30.5 degrees to the horizontal. So if I draw my compass rose, that is super crooked, it's descending, which means it's going down this direction, down. We start here in the middle, it's descending at 30.5 to the horizontal. The horizontal is right here, so it's descending 30.5 degrees to the horizontal. If the hill is 23 meters long, so here's the hill. If the hill is 23 meters long, what are the horizontal and vertical components? Well, my horizontal component is this way, and my vertical component is this way. So we're creating a triangle again here. And in order for us to find this, we have to kind of work backward. So let's go ahead and start with this side right here. This is going to be my distance in the x direction. I'll do the second. This is my distance in the y direction. Okay, I'm going to do this one first. So here we go. So first of all, I need to figure out, am I going to choose SOA, KA, or TOA? And I have, let's see, for this one, I have hypotenuse, and I have my adjacent. This is my adjacent. Let me go ahead and label these. Hypotenuse opposite of my angle here, opposite, and my adjacent. So I have my hypotenuse and adjacent. Hypotenuse and adjacent, that's going to be cosine. So I'm going to say the cosine of theta equals adjacent over hypotenuse. There's a bell. I want to get adjacent by itself, so hypotenuse, these cancel. So the hypotenuse times the cosine of theta is going to give me the adjacent. It's going to give me this side right here. My hypotenuse is 23. My cosine and my angle is 30.5. And that's going to get me, and you want to make sure you're in degree mode here, that's going to get me 23 times the cosine of 30.5, and I get 19.8. 19.8, and we're talking about meters here. Okay. So where does this go? This, the distance on the horizontal, or the x-axis right here, is going to be 19.8 meters, all right? Time for number 2. Number 2. Okay, so, again, we've got SOA, KA, TOA. Heck is that? Okay. All right, so here's my angle. I have the opposite. I'm going to use the hypotenuse. I could use this, but if I mess up calculating this, and I rounded, we don't want to use that. So I'm going to use opposite and hypotenuse. So hypotenuse, that's sine. So whenever I try to find the adjacent, I'm always using cosine. Whenever I'm trying to find the opposite, I'm always using sine. Okay, so let's go ahead and write this out. Sine theta equals opposite over adjacent. And I want to figure out what the opposite is. So let's get this by itself. I'm trying to get this one by itself. And multiply, oops, wrong thing. Hypotenuse, opposite over hypotenuse. Okay, so multiply by the hypotenuse on both sides. These cancel, and I have to do the same thing over here because those are the laws of math. Hypotenuse times the sine of theta is going to give me the opposite. Okay, so now I can go ahead and plug in my numbers here. Hypotenuse is 23 times the sine of my angle is 30.5. And I get 23 times the sine of 30.5. And I get 11.7, we'll call it. And these numbers, they make sense with this. So this one is 11.7 meters. Okay. So do we answer the question? A child rides a sled down a hill that descends at an angle of 30.5 degrees to the horizontal. If the hill is 23 meters long, what are the horizontal and vertical components of the child's displacement. And the displacement is this. The displacement is here to here. It's the resultant. Okay, let's move on to our next one. Number 2. Okay, number 2. If you walk 2 kilometers towards 248 degrees, how far south and how far west have you gone? Okay, we can do this 2 different ways, okay? So, and both ways are right. I'm going to show you both ways. Okay, so it says I walk, north, east, southwest, north, east, southwest. I really like drawing out the compass rose every time because it just helps me visualize what's going on. This is 0, 90, 180, 270, and 360. Okay, and so I'm gonna do this. I'm gonna do this side first, and I'll show you another way to do it over here. Okay, so it says you walk 2 kilometers towards 248. Okay, first predict. 248 is gonna be in between these two. I don't really know exactly where yet. I'm gonna do some math to figure it out, but I'm just gonna draw it in. So this is 248 degrees. And it says I walked 2 kilometers. So from here to here, I've walked 2 kilometers, and the direction is 248 degrees. It wants to know how far south and how far west. So how far south, well, let's start with west. How far west is gonna be this way, and how far south is going to be that way. Okay, I'm going to go ahead and get rid of this paper back here. So, I need to figure out what this angle is going to be. What is that angle? So in order to do that, well, this is 270. 270 minus this is going to give me this. $270 minus 248, and I get, hard to read that, 22. It's not a negative, there we go. So this is 22 degrees. All right. Now, let's go ahead and label our parts. So this right here is my adjacent. Okay, and this over here is my opposite. I don't have a ton of room here. And we can also call this the distance in the x direction or the west direction. You could call it dw, dx, whatever. And this is the distance in the south or in the y direction. You can call it whatever you want. You can just call it north, it doesn't matter. I'm just labeling like that, just so that way we have a label. I'll do this one first, and I'll do this, in that one second. Okay. So one here, and then I'll do the second one over here. Hopefully I have enough space to do this. Okay, so here we go. So I always start off with SOHCAHTOA. And for my green side, that is the adjacent side. Adjacent and my hypotenuse, so I'm going to use cosine. So the cosine of theta equals adjacent over hypotenuse. Okay, I'm going to multiply the hypotenuse on both sides. Cancel, cancel. My hypotenuse times my cosine theta is going to give me my adjacent. I'm just writing a little bit differently because I'm running out of space to do it over here too. My hypotenuse is 2 kilometers times my cosine of theta is 22. And that's going to give me my adjacent. Let's plug it in. 2 times the cosine of 22, and I get, I'm going to call it 1.85. 1.85 meters. so that is this 1.85 meters. Let's do, so they're going 1.85 meters. Oh, I should probably label this west. Okay, and for number 2, again, we look at SOHCAHTOA, use black. And think about what we're going to use here. We're looking for the opposite in the hypotenuse. So opposite hypotenuse, that's sine. So the sine of theta equals opposite over hypotenuse. I multiply by the h to get the O by itself. Hypotenuse times the sine of theta is going to give me my opposite. My hypotenuse is 2 kilometers times the sine of 22, and that's going to give me my answer. Oh, I'm running out of space here. 2 times the sine of 22, and I get, I'm going to call it 0.75. Okay, and this is going to be, I don't have very much room here, but this is 0.75 meters, and this is the south direction. Okay, it's that's for this one right here. All right, so this is one way to do it, and I'm going to show you another way to get the exact same answer. Okay, so we said that this is going to be somewhere right in here. And another way you can do this is, we said that this whole thing right here, all this, is 248 degrees. And so if we wanted to figure out, what if we didn't get this angle? What if you said, Miss Moore, no, I want to use this angle? Okay, that's fine. How do we do that? Well, I'm going to do 248, and I'm going to subtract 180. And I get 68. So this angle right here is 68. Now, if you're someone who's struggling with like the angles, one thing you can do is you could just, do some, like over here before when we had 222 as our angle, well, 248 plus 22 should give you 270. So you can always check yourself. Great, okay, I got 270, okay? It's just a little, just adding and subtracting, just getting used to visualizing and resolving and figuring out your reference frame. This is called like resolving, trying to figure out the direction, and our reference frame is north, south, east, west right now, so as opposed to the x and y axis. All right, so how do we do this? Well, the exact same way. My y-axis is literally, it says it wants the south and the west. So south is still this way, and west is still this way. And what actually I do here is, you see how I basically take this and I move it down here. I take that and I move it over here. So watch this. We are going to get the exact same answers. Don't believe me, just watch. Here we go. Okay, we're gonna do 1 and 2. Okay, so let's put this 2 right here so I don't overstep my bounds there. Okay, so again, SOHCAHTOA. Which one am I gonna choose? For number 1, that's this one. Now I'm gonna use the sine and the hypotenuse. Oh my gosh, these are supposed to be kilometers over here, you guys. Kilometers, sorry. Okay, back over here. Okay, so 2 kilometers. I have the angle, and I'm trying to figure out 1, and I have the hypotenuse. So this is my opposite. This is my adjacent. Okay, so I'm going to use opposite. I'm going to use sine. So the sine of theta equals opposite over hypotenuse. Multiply by hypotenuse. Cancel. H times the sine of theta equals my opposite. Okay, so now my hypotenuse is 2 times the sine of 68. So here we go. 2 times the sine of 68, and I get 1.85 kilometers. Aha! It's the exact same thing as we got last time. Okay, let's do the other one real quick. So now we're trying to figure out 2. Here's my angle. Okay, it's adjacent and hypotenuse. So adjacent hypotenuse, that's cosine. cosine of theta equals adjacent over hypotenuse, multiply, cancel, hypotenuse times the cosine of theta equals my adjacent. 2 times the cosine of 68 is going to give me 0.75 kilometers. And that is what we got last time. So you can see there's a lot of math here. You don't have to do it both ways. Just pick one way, whichever way your brain thinks, and it will get the same answer. This one is using this angle, and this one's using this angle. But you can see that they're the exact same thing, right? We're just sliding this over here. We're sliding this down here, right there. Okay? I hope this helped.